Alright, so we're back with more exponent properties. This time we're going to focus more on the division side of exponents. So this first one we're looking at is the quotient of powers. Okay, and real simple, it's just a to the m. If you divide it by a to the n, it's the same thing as doing a, because it's the same base of a, just doing m minus n. Okay, and of course you cannot have a equal to 0, because that means you'd be dividing by 0, and you can't do that. Okay, I'm going to prove why this works. So I'm going to do a to the third power divided by a squared. Okay? So if we have, based on this property we have right here, a to the m minus n, I would just do a to the 3 minus 2. Just following along with what we did up here. Okay? A to the 3 minus 2 would be a to the 1, which is equal to a, as you know. Okay, now why does it work this way? Okay, well I'm going to break down this a to the 3 to be a times a times a. And then this a squared, a times a. Now if you know, any number divided by itself is going to be equal to 1. It's going to cancel out, so a over a, that cancels out to 1. This a over a cancels out to 1, and you end up with just 1a left, which is the same as when we use this property up here. Okay, so that's quotient of powers. Next we're going to be going over the power of a quotient. So in this case, we're taking a quotient and raising it to a power of m. In this case, it's similar to the multiplication where you would just take a to the m divided by b to the m. Okay? Of course, b cannot be equal to 0 because you'd be divided by 0 and you can't do that. So, well, how does this work? Well, I'm going to do a over b to the third power. Okay? Based on our property up here, we should get a to the third divided by b to the third. All right? Well, let's test that out. A divided by b to the third power is the same thing as saying a divided by b times a divided by b times a divided by b. Okay, if you remember your rules for multiplying fractions, you just multiply numerators times numerators and divide it by denominators times denominators. So that's what I'm going to do. A times a times a is a to the third divided by b times b, which is b to the third. And as you can see, our answers match up. Okay, so that's power of a quotient. Next, we're going to show zero exponents. Okay, as you might know already, a to the 0 power, any base to the 0 power, except for 0, a cannot be equal to 0. I should add that in. So a cannot be equal to 0. 0 to the 0 power is not 1. Okay, now how do we prove this? Well, I'm actually going to use the quotient of powers to prove that any number besides 0 to the 0 power is 1. Okay, so for this exponent to be 0, that means that m minus n, m and n have to be the same number. Okay, if m and n are the same number subtracted by each other would be 0. 3 minus 3, 2 minus 2, 100 minus 100, you'd always get 0. So what I'm going to do is do a is equal to 3 minus 3. Okay, to the 3 minus 3 power would be the same thing as saying a to the third divided by a to the third. So I'm going to do that. A to the third divided by a to the third. Okay? Well, let's simplify this out a little bit. A times a times a would be a to the third. A times a times a for this one would also be a to the third. This cancels, this cancels, this cancels, and you end up with 1 over 1, which is equal to 1. So as you can, this kind of proves right here that any power, any base raised to the 0 power is going to be equal to 1. Okay? Because they're going to cancel each other out. You're going to have 1. Okay? Next, we have negative exponents. Okay? If you take 1 and you divide it by some variable, but a can't be equal to 0, you end up with that same number, that same variable as the base to the negative 1 power. Okay, now I'm actually going to use the 0 exponent to prove that if you take 1 divided by a variable, you get that variable to the negative 1 power. For this 1 up top, I'm going to use a to the 0 power because 1 is equal to a to the 0 power. I'm just going to turn that 1 into an a to the 0 power and then divide it by a, just like up here. So all I did was substitute in for 1 the a minus 0. A to the 0 power, I'm sorry. Okay, so from here, I'm going to use my subtraction rules from the quotient of powers where you just take the m minus the n of the two exponents that you're using in the division. Okay, here it would be a to the 0 minus, this is the power of 1. So I'm going to put a 1 in here. So a to the 0 minus 1 is equal to a to the negative 1, which proves what I have up here. Okay, so I'm going to do the exact same thing now with this last one. So it's a equals 1 over a to the negative 1. Again, a can't be equal to 0 because you'd be doing the inverse of 0. We can't do that. Okay, so I'm going to say a is equal to, I'm going to substitute the a to the 0 power again up top for the 1, divided by a to the negative 1. We're going to use our quotient of powers rule again, where if we're dividing two numbers that have a similar base, all you have to do is subtract the exponents. So I'm going to do, this will be a to the 0 minus negative 1. Okay, 0 minus negative 1, a minus and a minus together would make a plus, minus a negative makes a plus, so you end up having a to the 0 plus 1 equals a. So if you notice, I have a here as well as a here, so it proves that this works as well. So these are some more exponent properties. If you have any questions on any of these, let me know.